नमस्कार, आप सबका स्वागत है रीजनल साइंस सेंटर भोपाल की इस खास पहल में। हम फिर से तैयार हैं एक खास स्पेशल पॉडकास्ट को लेकर। आज इस पॉडकास्ट में हमारे साथ एक रेनाउंड सेलिब्रेटेड एस्ट्रोफिजिसिस्ट हैं। ऑन दैट नोट वी वुड लाइक टू इंट्रोड्यूस टुडेज guest who is very special for us, and we are very much thankful to him for accepting our request to visit Regional Science Center Bhopal and also featuring on that particular podcast. So before introducing today's speaker, let me tell you one thing. Today's episode, the quantum quest, exploring inner core. But he is known for exploring outer universe. So we have very special guest, Professor Duncan Lorimer, Eberly Distinguished Professor from the West Virginia University, United States of America. He is renowned for his work in the field of, fast radio burst and transient events like pulsar. He is also member of Royal Society, we call fellow of Royal Society, and other prestigious body internationally. He has received many awards, including South Prize in Astronomy, and his work has, made us very, very interested in the field of radio astronomy. So we are welcoming you, Professor Lorimer.
Oh, thank you very much. It's my pleasure to be here. Really happy to be in Bhopal.
So how are you liking Bhopal climate?
Oh, it's very pleasant. Yeah, I just came from Pune, which was a little bit warmer, but now the air here is clearer and the temperatures are nice and cool. I'm having a great time.
That means from Mumbai climate to Pune to now Bhopal.
Yes. So this is my favorite.
Oh wow, thank you. So we call in our state in India, central India, heart of India. So thank you, and we once again welcome you in the Regional Science Center Bhopal. It is a unit of National Council of Science Museums, an autonomous scientific non-profit organization functioning under the Ministry of Culture, Government of India. In this podcast series, we try to explore inner core of an individual, and in this case you are our guest.
Okay,
so let us start from your school days. So how do you see your journey from your school days? Which was the most important phenomena or event which actually pointed you towards the science?
So I grew up in a small village in the northeast of England. Village is called Cotherstone, and it's just about 40 miles south of Newcastle, which your viewers may have heard of. So just a very simple existence. I was in a family of 5. I have 2 brothers, and my parents, encouraged us all to be curious about the natural world. And I went through, primary school and then secondary school. It wasn't really until I was in 6th form, towards the end of my schooling, that I got really interested in astronomy, and I had the opportunity to actually use a telescope. So at that time I had some friends who were also like-minded, and the teacher gave us the keys to this old telescope, and he said, just go and have fun with it. We observed a lunar eclipse, and that's kind of where I got really interested in astronomy. Yeah, that was the beginnings for me.
That means schooling is very critical in our future journey as well.
Yes, it is. It's so important to be open-minded and just try. You'll never have as much time, as a youngster to absorb all of this material and take every opportunity that comes your way.
Thank you. And how actually you encountered during your college days, what was the main point of concern, or maybe one fine day you decided that I'll pursue my career in the pure astronomical research? So your undergrad studies, your PhD.
Right.
So actually we'll be happy to know about your experiences during those times.
Right, yes. So I left home almost 40 years ago. So at that point, I had this telescope experience, and I liked astronomy. My favorite subject at school was mathematics. So that was what really interested me the most. I remember, thinking about abstract quantities, or infinity still is very, very intriguing to me. And so I wanted to use that mathematics for something, and so I took the opportunity to study at the University of Wales in Cardiff, and there it was an astrophysics degree. I really, though, I wasn't a keen amateur astronomer. I hadn't been thinking about it my whole life. So I was just at that point learning and absorbing as much as I could. And it wasn't until my final year, my third year in college, that I learned about neutron stars. And that's what really, really gripped me. My favorite subject, at Cardiff was gravity, and learning about, Einstein's view of gravity and how it, built upon what Newton did, but take it a step further. And then you have these exotic objects that you can use Einstein's theory to describe. And so when I learned about neutron stars, I was hooked really from that moment on. I loved astronomy, but I was never drawn to one particular object like I was towards neutron stars.
So what was the time when you were talking about neutron star interest in your college date? What was the year? Which was the year?
That would be when I was leaving college. It was about 1990. So I was at Cardiff from 87 to 90.
My goodness, that's England.
Yes.
And you are saying one exotic object like neutron star, which pulled you towards your curiosity,
right?
So that you can have your longer career in the field. Actually, it's really interesting, and how your school and college life can shape your critical understanding. So how you actually landed in the research? You pursued your PhD, then your postdocs in US also, then your faculty positions in UK, then US, and then your career, little bit observation from Australia also. So we'll be happy to know your experience.
Yes, yeah. So I left Cardiff in 1990. I knew, I'd learned about these neutron stars. I was interested, but I still really didn't know what to do with them, how to even study them. And so my advisor, Bernard Schutz, who's still a good friend of mine, he said, you need to go to a place called Jodrell Bank, which is, a very famous observatory in the UK. It's just south of Manchester. And in my naivety, I had not heard of it. I had no idea about Jodrell Bank, literally no clue. And so I took him at his word, and I said, yes, I'm going to go there. And he said, you need to study with this person. His name is Andrew Lyne. And I said, okay. So I applied, and I got an interview, and I caught the train up there. And I remember arriving at the station, and these muddy fields, and it was just in the middle of Cheshire. And then we drove around the corner, and I saw this giant radio telescope, which is now the Lovell telescope. It's still an iconic structure. And that's what really got me very interested. The fact that we could use these telescopes to study neutron stars, and that connection has stayed with me ever since. So, throughout my career, I was at Manchester for it was almost 4 years by the time I left Manchester. Actually, now it was 5 years, because I stayed on an extra year after I graduated. And at that time, I'd started to do observational studies of neutron stars, so pulsars, these rapidly spinning neutron stars, so learning about them. And I got incredibly interested in the population of pulsars in the galaxy. And then that took me as a PhD student to Parkes, the observatory in Australia. And so, as you mentioned, I had a long relationship with that telescope. And as a student, I was very fortunate to go to Australia multiple times. That trips there brought me back through the US. So I began to learn about this worldwide community that studies pulsars. And that's what then, inspired me to go further. After I graduated, I was at Manchester for a year, and then I went further.
That is quite interesting. And as I asked earlier, your train journey, that
Yes.
was the eureka moment in your life, because you saw the first time the bigger radio telescope.
Yes.
But I was also referring your Australia visit, because northern hemisphere, southern hemisphere,
Yes.
northern sky and the southern sky.
Yeah.
And for your astronomical journey, when you were talking about gamma ray, this fastest radio burst, the source near to a large Magellanic cloud.
Yes.
So that's in the southern night sky.
Yeah.
And that can be easily viewed from the Australia and the southern part of our planet, or in the night sky.
Right.
So that's interesting connect from your journey. So what actually drove you to choose scientific career, especially in this field, like a fastest radio burst or transients event like pulsar? What motivated you to choose this very narrow
Yeah.
down research approach, very specific to these areas?
Yeah, so I was very interested in the objects, the neutron stars and the pulsars. But once I got over that initial interest, I wanted to like understand them as a population. So my thesis at Manchester was studying the distribution of pulsars in the Milky Way. And so the way I describe it, it's very much like when you carry out a survey of the population of humans to find out what they're going to vote in an election, and you carry out a poll, and you take a survey, and then you try to predict what's going to happen in the election. Sometimes you make mistakes and you don't quite get it right, but often you can forecast what's going to happen. And so that's what we do with pulsars and other astronomical objects. But that's what really drives me, is to understand them as a population. And so throughout my career, my surveys are using telescopes to survey regions of the universe. And yeah, so the pulsars were always the driving force there. Occasionally you would find quite often actually, you would find an interesting individual pulsar, and that would take you down a rabbit hole to study. But then I'd always try to recenter myself and think about the population again. And that's really how we ended up stumbling on fast radio bursts.
For the audience, for the viewers, for the Science Center's visitors who are watching or may watch afterwards this podcast, can you introduce the very interesting object like lighthouse of the universe, pulsars?
Yes.
So that they can have connect.
Right. So pulsars, I now use the word pulsars and neutron stars synonymously. But pulsars are rapidly spinning, highly magnetized neutron stars. And so they have, like the Earth, they have a north and south magnetic pole. And that magnetic pole forms a beam that accelerates, so the magnetic field forms a beam which is due to the acceleration of particles from the surface out, much like a lighthouse, in a certain direction. And like the lighthouse is spinning on the beach, we see the flashes of light. So the pulsars spin across the galaxy, and we see these pulses of radiation from the Earth with these lovely large telescopes. And that's the basic phenomenon. We call it the lighthouse phenomenon. We can use that to identify pulsars, but then once we find them, we can study them over long time scales and learn more about their individual properties. For one example, we can study how they're spinning down. They're actually losing energy because they're radiating out along their magnetic field. That's causing them to lose rotational energy, and we can watch them slow down, and that tells us about the evolutionary processes.
That's quite interesting.
Stars, yeah.
As we call light, for common man, for all of us, light means visible band.
Yes.
And for astronomers, light means whole electromagnetic spectrum.
Right.
So you are saying the pulses which we are receiving through pulsars, those are in radio waves.
Mm-hmm.
Am I correct, sir? Those are in
radio?
Radio?
The ones that we study are in radio waves. The neutron stars themselves, they're one of the few objects that emit over the whole electromagnetic spectrum. It just turns out, though, that the radio waves are easiest for us to detect on the Earth.
So have you observed any redshift?
From a neutron star, not directly, because the neutron stars themselves, they don't really have a spectral line in the way that a star does, or a galaxy, a collection of stars does. The neutron stars just emit these radio pulses. What we can see, though, is when pulsars are orbiting around another star, we see the Doppler shift of their pulse period due to the orbital motion.
Coming towards you and going far from you.
Yeah, so there's a red shift and blue shift associated with that.
Mm-hmm.
Yeah.
But have we observed these objects beyond our galaxy for the audience understanding and our Milky Way or beyond Milky Way? Mm-hmm. Have we observed such astronomical events beyond our Milky Way?
So these neutron stars, yes, they have been known not just as Milky Way objects for quite a long time. So our colleagues in X-ray, in the X-ray part of the electromagnetic spectrum, have found X-ray emitting neutron stars in external galaxies. That is quite a well-known phenomenon since the 1980s. The radio story kind of goes out to the Magellanic Clouds, and in the 1990s we started finding pulsars in these small satellite galaxies to the Milky Way, the Magellanic Clouds.
Okay, that's
Yeah.
great. So as our universe is accelerating, Edwin Hubble has exactly showed us that evidence that universe is expanding.
Right.
So we are talking about radio, but as you said, pulsars are also emitting in all wavelengths.
Yes.
So they may be also one kind of candela of light source, which will help us to understand through redshift the expansion, and we can go deeper in the universe to understand at that point in time what actually happened.
Yes, and so it's about 100 years ago that we learned that the universe is expanding. And so, the promise is, if we can find these sources in external galaxies, then we can use them to help us understand the large-scale properties of the universe. Yeah.
Quite interesting. So, sir, now you are in this field since a very, very long, and 20 years you have spent at the West Virginia University as a professor.
Yes.
You have been teaching other than research also, writing. So what was the moment when you decided to use that archival data?
Yes.
And you ask your students that let's start have an analysis of the data.
Right.
That actually made a remarkable contribution in the field of first radio burst.
Right.
And later on it is no more first because many people observed,
Yes.
you said.
Yeah.
So we'll discuss a bit very quickly about repetitive and non-repetitive. We don't want to go much deeper in that.
Right.
For the audience, it would be always interested so that they can ask questions in comments also.
Right.
But you may actually take us on the journey on particular time frame when you and along with your PhD students,
Yes.
you were thinking that let's have a archival data.
Yes,
And how you have decided, what was the moment which were responsible for taking that decision?
Yeah, well, like many things in science, there was a lot of luck involved. So we just arrived at West Virginia University 20 years ago, almost 20 years ago to the day. So when I say we, I'm talking about my wife and I, Maura McLaughlin and myself. We're both astronomers. So we are an astronomy
Family.
couple. So we arrived there with our young son, who was 9 months old at the time. And we began our journey as assistant professors. And so the goal there, any university in the US, and I think it's the same is true in India and many parts of the world, is to get undergraduate students involved in research. That wasn't the case when I was an undergraduate, by the way, but it is more common now.
Okay.
So the reason that we wanted to use archival data was that we just wanted to get going quickly. So we didn't want to go out and collect more data with the telescope. We already knew that there was some really nice data sets that we could look at and look for individual pulses from these neutron stars, because we knew that those hadn't been searched in that way before. So we thought, well, maybe we can find some individual pulses in the Magellanic Clouds from pulsars in the Magellanic Clouds.
LMC, large magnetic
yes,
or small.
Both of them, in fact, yes, the LMC and SMC. And so that's where it began. So it was just a fortuitous decision to start analyzing those data. We had an undergraduate student at the time who was helping us with that. And it was a nice project in the sense that you could just put it onto a desktop computer and it could get through the data on the time scale of a few months, which is nice for a student because they can look at some data and then go and attend classes, and then it's just a very nice time scale. So that's where it all began. We found the first one a few months after we started, and for a long time that was the only source. It was a very bright event that was about 100 times brighter than our detection threshold, so it was really quite surprising to find something so bright. But then, when we checked where it was in the sky, it actually wasn't coming from the large or small Magellanic Clouds. It was coming from just a random point just below it, and really as though we're just looking out into the universe. So we suddenly started coming to terms with the fact that this pulse was not anything to do with these galaxies or even our galaxy. It was actually coming from way beyond the Milky Way.
Oh, great.
Yeah, that took a while for us to get our heads around that.
And how you felt afterwards, that was named after your name, Lorimer burst. And the whole world is now referring that
Right.
that's your biggest contribution. So
Yeah.
we are really once again thanking you for accepting our request, because the way you have contributed that understanding that may reveal some open questions one day. These are fundamental building blocks.
Yeah.
We are heading towards some better understanding of our universe. So how you felt afterwards? People are referring it Lorimer burst.
Well, I mean, very flattering to have a burst named after me, or anything named after me. And that the person that started that was my former advisor, Matthew Bales, who was part of the discovery team. He's very good at publicizing things and attaching names to things. And so yeah, Matthew started that. It was also frustrating though, because for about 6 years we only had this one detection. And so if you're gonna claim a new astronomical phenomenon, you better find the other ones that that presumably are out there. That was our prediction, that the universe was filled with these bursts.
That's the beauty of science.
Yeah.
You have to discover, analyze, and explore, and you cannot sure, because universe is having its own journey.
Yeah.
Universe is not committing to us to answer everything
Right.
in our time frame.
Right.
we need to wait.
Yeah,
As we
right.
discussed earlier, Einstein never thought in future these gravitational wave may discover in his lifetime, or maybe in
Right,
future
right.
also, very near future. But after 100 years, almost
Yeah.
after 100 years, gravitational wave actually were discovered. And
Right.
for that, your LIGO is one of the important
Right.
scientific experiments.
Yes.
India is also
Yes.
one partner of that mission.
Yes,
Like
that's
Hanford,
exciting.
Louisiana in the US, 2 detectors, and one is coming up in India, in
Yes.
Maharashtra.
It's very exciting.
So
Yeah.
that's how these are interesting ones. Thank
Yeah.
you. And how do you see, because this field is now flourishing, and mega science projects are coming up, and astronomy, astrophysics are now much more advanced in terms of computing power also.
Yeah.
We have good computing analysis, database,
Yeah.
well structured pipeline
AI.
of softwares. Now we are using artificial intelligence also globally. So how do you see that particular time frame when people can think to choose a career in astronomy, or maybe more precisely in astrophysics?
Well, I mean, we were fortunate in the sense that we could make our discovery with a small team. We were just analyzing some data, and then we made this discovery. But it's to really get to where what we know about fast radio bursts today is required these mega collaborations, as you just mentioned, and that is essential. So that requires building instruments, getting teams of people together to actually deal with the data, write algorithms, come up with algorithms, implement them, all of that. But it provides just such a rich environment to get the next generation of students excited about science and training them to go off into other things. So my personal preference these days, I've been in some large collaborations, and now I'm sort of moving back to smaller projects again. Both are important, and what I see our role as astronomers really is just helping to train the next generation of scientists in general, whether or not they stay in astronomy.
That's a big question,
yeah.
but that's always an
Yeah.
interesting journey.
Yeah.
It's like a train you have boarded to
Right.
go see the radio telescope,
Yeah.
as per your advice by your guide.
Yes,
So
yeah.
that moment of time actually motivated
Yes,
you
yes.
in this direction. So that's correct, sir. And how do you see, what is your take on the role of science, why it is very important for all of us, especially for the youth and the young minds who are watching this program? If they want to make a career in the field of science, so
Right.
why science is important, not only for the school, college,
Yeah,
or university
right,
researcher,
right.
even for general masses, the way science centers are taking science messages in the society.
Right.
So what is your take on it?
Well, I mean, my take is fairly straightforward. I think every country should really be investing in science in a fundamental way, because really it's part of their national security interests. Without a well-trained population of scientists across all areas, they're going to start to fall behind other countries in a rapidly shifting world. And so you want your young population to be as well educated as possible, and that's how you're going to stay at the forefront of these discoveries, contribute to more discoveries, and really just keep your own homeland safe. So I view it as really important for the country as a whole to have scientists.
What is your message to Indian students? Because I came to know that many Indian students also were part of your area,
yeah,
like
right.
Sihar Tandulkar, like
Yes.
Mukherjee,
Yeah.
Mayuresh, and
Yeah.
many more.
Yeah.
So, what is your message for Indian students who are in schools now, in colleges? What you want to say to them?
Right. Well, I mean, follow your dreams, but also work hard at school. You know, really focus on the fundamental subjects. You know, mathematics, literature, and the basic sciences. Just really drill down on those. I think that's a key message. I'm here in India for the next 6 weeks or so to visit various places and meet with young students. And so far I'm just overwhelmed with the enthusiasm that I see. There's clearly a lot of there's a big appetite to get into science, and so my message is don't be afraid that it seems very overwhelming, right? When you're starting the subject to learn about all of these discoveries, but just use your time that you have right now to survey, to do a survey of the topics and find which one you're really interested in. You might find that the first one you study, it's interesting, but it's not what you really want to do. And so keep on looking for inspiration that way.
One day you may encounter with your own FRP.
Yes.
Fast radio was in interested
Right.
area.
Right.
That's great.
Right.
That's great. So at the end, before wrapping up this session, so what is your message to our science centers visitors? Because Regional Science Center Bhopal, which is a unit of National Council of Science Museums,
Right.
and in India, our council is having 26 science centers across many places under the 5 zone.
Right.
So we comes under the West Zone. Nehru Science Center is our Western Zone head office in Mumbai.
Right.
And this Regional Science Center Bhopal is serving in the state of Madhya Pradesh, capital Bhopal,
Right.
for the state of Madhya Pradesh. So what is your message for the visitors to visit about Science Center? And how do you see exactly your own view and perspective for visiting Science Center?
Yeah, I mean, I view places like this, these science centers, as just essential. They really complement what's going on in schools, and they bring it to life. Honestly, you have all of these interactive exhibits that we have here at this center, and all around India and around the world. My advice to people is not only to come frequently, because the exhibits change and evolve, and you can never absorb anything in one visit. But the other thing is to tell your family and friends about it. And the more people that come to these facilities and learn from them, the better we'll all be as a humanity and as a country in general.
Thank you so much for giving your time.
Thank you.
Thank you. And this was the episode. We brought one special guest today, like other previous episodes. And this episode was featuring Professor Lorimer, Duncan Lorimer, Eberly Distinguished Professor from West Virginia University of USA. And he was with us today. Thank you, Professor Lorimer.
My pleasure.
And now I'll request to all of you for keep learning and engaging yourself in the world of curiosity, and always follow your passion and dream. And you are most welcome to visit Regional Science Center Bhopal. It is very much accessible to you. It is situated at the Smart City Road, which we call Ganga Road, on Smart City area. Very popular, very interesting place where you can have your hands-on experiences with your family, friends. So keep learning and visiting Science Center, and don't miss it. Not only for science, for entire society, role of Science Center is very important. So thank you everybody for supporting Regional Science Center Bhopal in its initiative on various fronts. So this was the podcast episode, The Quantum Quest. Before wrapping up, I'll request to you all to keep in touch with us digitally for about activities and updates. On your screen, you will see a QR code. That code can be used for you to use your smartphones, follow our Science Center on various platforms, Instagram, Facebook, and that would be interesting journey, and that makes a physical visit.
Right.
That's very interesting for learning. Thank you, everybody. Thank you, sir.
Thank you.
Namaskar.